Hello, hello. Welcome to today's training. I'm excited about this topic, and we have a tremendous amount of interest in this one. And we're excited about this one too, because we're an implementation partner for Cursor, recently acquired by SpaceX. And so we're helping clients adopt AI-driven development with Cursor. And I want to showcase today all the different aspects of how to use Cursor, but most importantly, how to get the most out of it when using AI-driven development and when really up-leveling the team's capacity to deliver world-class results. So we have a lot to cover, and we only have a short time to do it in. And so I'm gonna get going. Now, using Cursor doesn't automatically make your software faster, just like every AI tool. It doesn't automatically make your software faster or safer or more stable. How you architect around it does. And I've been helping teams get better and deliver world-class results for my entire consulting career. I've been in consulting for over 20 years, and I've been developing software for almost 30. And so I want to steer you away from some of the rookie mistakes and point you in the right direction. You're going to walk away knowing how to delegate the right work to Cursor versus staying hands-on, typing the code yourself, how to delineate between those, how to measure whether quality and stability and delivery speed are actually improving, and how to report return on investment to leadership in terms that really make sense. So, what we're going to cover. We're going to cover the Cursor platform, all the different flavors, everything around it. We're going to cover AI-driven development, and then we're going to put the two together. And we're going to cover the software factory pattern, which implemented in your team, in your software organization, brings all these related concepts together to actually turbocharge your software delivery. So there's a lot in there. All right, starting out. Um, AI, it's an era in software development, but it's not just another tool or technology. It's a new paradigm. Each of these prior transitions has really reshaped how teams build software, and AI it's kind of a change in what software is, not just a little detail. And so let me walk through the transitions really briefly. With the internet transition, we connected all computers. Before then, computers weren't perpetually connected. And Agile, when Agile started, we focused on smaller batches, and it helped us realize that we don't know the right answer for which feature or software behaviors is going to work in the marketplace. We have to test, we have to iterate, and the users in the marketplace are the test bed. In the mobile transition, we went to all-time computing. We took the computer with us. It was in our pocket. With the DevOps transition, we began extending everything we learned with the agile engineering practices to agile system administration. We learned how to apply small changes to infrastructure as well. And as an industry, we learned the beginnings of dynamic scaling and safe server and infrastructure changes. With the cloud transition, we learned on-demand infrastructure. Every prior era has required kind of a special person who knew the language of the computer. And our job was to make the software speak the language of the business because computers inherently speak a specific language that software engineers, us, we had to know, we've learned. And in even simple informational websites for mom and pop businesses had to be painstakingly coded by someone who knew programming. Well, now we have this era of artificial intelligence, which is the GPT era, generative pre-trained transformer with the language models, where computers can simulate language. And this bridges so many scenarios. Programs can simulate speaking in languages all around the world. And really, any task that requires generating text can is open to this world now. And so we can now stitch together many computer tasks into full workflows, and the whole world is discovering how to automate more and more, and certainly with custom software. Okay. So let me bring a big idea. Big idea. The surgical team returns and is here. The old Fred Brooks's surgical team model. If you haven't read the book by Fred Brooks, The Mythical Man Month, I highly recommend that you do it. Um, and basically the premise of that is in an operating room, you have two competent professionals, two surgeons with the hands in the patient. And there's kind of only room for a small number of hands in the patients, but the room is also filled with other roles that are important to make sure the surgery goes well. But you have two people who know how the inside of the body intimately works and the hands in the patient. Same thing with software. You have a small number of people with the fingers in the code in the software, but then you have other roles that help make sure that the project goes well. Okay. Um, and so I want to bring that into some really timely research by McKinsey and Company, and I've included the link at the bottom of this slide. And it's a great article based on some research called Rewiring Software Delivery for the Agentic Era. And it was just in May of 2026, very recent. And it's talking about the micro teams, the software pods, the feature teams, really being a very, very small number of people for a particular outcome, and that comprises the software organization. So you might have a big software operation, but then you take a major feature and then you put in there a small number of people and work like that. And so how it might work is you have a market expert. You might call him product manager or whatever title you have for him, but you have a market expert and you pair them with a technology expert, and that could be a pod. And that's just two. I mean, maybe you have three, but a lot of teams are adopting this two-person per pod for kind of feature teams or feature pods, where you have someone who's really, really a subject matter expert on the market, on the way the users need to use it. And then you have a software engineer, a technology expert who actually understands what's going on under the covers. And that pod is responsible for a feature. And now that so many constraints of the mechanics are really going away with AI tools like Cursor, that teams are adopting this with great success. Okay. Now, so I want to talk about what is a software factory, because this is where we bring it together. I want you to understand what I mean when I say software factory. Well, let's talk about factory first. The Cambridge Dictionary defines factory, a little bit of paraphrase, it has a little bit to this, but it's a place where large amounts of goods are made using machines. And and I want to focus on the word machines because we are there. You don't put a human inside the machine. Experts design the machines, and then we place them in the right spot. We feed them raw materials. We keep them running. So AI-driven development raises the bar for senior engineering expertise. Way back in early 2000s, there were some people who tried to float the idea of a software factory that was basically based on cheap labor and a software factory comprised of people doing highly standardized things. It didn't work and it fizzled out. And so for those of you who were not working in the early 2000s, you don't know what I'm talking about because you don't remember it. But there was a concept. Factories are machines. Well, now with artificial intelligence, the different machines of the Cursor platform, we have the machines actually necessary to create a software factory. All right. Um, so, anytime a factory is constructed, we put together assembly lines of these machines, and they have to keep going, and they have to be fed, and they have to be organized, they have to be maintained. And so the actual engineers who design and operate these machines intensive factories are very senior engineers who know what they're doing. And so that's super important with an AI software factory. And I'm going to highlight that a little bit more. Okay, before we get into our first demo, um, I want to talk about kind of the flow of the assembly line. First, you have the backlog, and then you go into your software development lifecycle, and that produces release candidates of software that get deployed to different environments, of course, all the way to production where the users are using the software. And so our factory, what does it have? It has machines, and each machine is in a station of work. And so we deploy those machines. We need them to run reliably. No factory can output good finished goods using unreliable machines. And so we've all seen where you put a prompt into a large language model and you basically get back slop. You get back stuff that's not usable. It's not good. And so we can't have that. We can't have an unreliable machine just giving us code that we don't like, right? So we have to build this so that we get designs and tests and code and scripting and all so that we like what we get. And for a software factory, we apply DevOps thinking, and then we add the AI automation. And the assembly line in the factory is a series of stations of work. Each station has exit criteria for what it means to have good output from that station of work. Then we automate the evaluation of that exit criteria because uh, some people are talking about human in the loop. Well, my view of human in the loop is a person operating the machines of the software factory, not doing part of the work, but operating it. If you are operating uh, adaptive cruise control in your car, yes, you're making sure that it's doing the right thing, but you take your foot off of the accelerator. Okay. So human in the loop doesn't mean that you're still pressing the accelerator. Human in the loop means that you're aware. You're in the loop. You're in the know. Okay. That's how I think about it. And you want all of the work to be visible. So we need to measure the entire assembly line, and that learning fuels improvements, and we improve the machines on the assembly line and the process and the exceptions that might happen from time to time. And so when we operate this, we're dealing with exceptions. We're not the worst thing. The worst idea that I've seen surfaced is that our software engineers are going to be reviewing pull requests. To me, that is impractical. Um, the productivity that we get, it increases the rate of pull requests. And if I am going to have to personally review every single pull request, then well, now I'm just a different bottleneck. And I'll tell you one thing: the type of software engineers that I have hired for my entire career, if I told them that their job is now uh, to review pull requests of code that is written by AI, two things are going to happen. One, some of them are going to say, "No, I'm not going to do that. I'm going to quit, go to another company." Okay. And the others are going to say, "No, I'm not going to do that, but I'll build a machine that does it automatically and does it well. But either way, I'm still not doing that." Okay. So it's one of the dumbest ideas that I've heard is that real software engineers are going to be personally reviewing the pull requests. Now, do we still need to ensure that everything is good? Yes, we do. I'll come back to that later on. But we need to make sure that all the work is visible. And then we run through small batches of work. We learned that from Agile way back 2 decades ago. And we focus on continuous flow. We learned that with Kanban. And so we continue to apply that. And in the AI software factory, we automate 95% of the work. And we're going to see what that might look like and how that might be implemented using the Cursor platform. Okay, we're going to demo. So we're going to demo a regular work tracking board. We're going to use GitHub projects for that, and we're going to show continuous flow. We're going to show some skills and using sub agents, the command line flavor. We're going to talk about the iPhone flavor of Cursor. We're going to talk about how to handle production incidents. We're going to also integrate the Cursor Grokbot team, and we're going to have lots of things running in parallel. So why don't we get into the demo? All right. And I'm going to show you a really quick application that we're operating on just so that you have context. Okay. So let me pull up this application here. Top. Okay. So here's the application, by the way, log out. log in. I can log into Summit. I have a just for a demo application. There's no password on this. We're going to log in as Timothy Lovejoy. And for those of you who are fans of The Simpsons, you'll recognize the theme of the First Church of Springfield with the Reverend Timothy Lovejoy. And we can create work orders. We can assign it to groundskeeper Willie, to mow the grass, and we can do all that. That's basically a very simple application. Of course, we have an AI agent. Have Drew Willie mow the grass, and we can just create a work order like that, and it should come back pretty quick. And then when it does, we can go to the search screen, and we can see that they're creating a sign. Okay, E10E, and my work orders. If I go to the bottom, E10E, that's the one we just created, mow the grass. Okay, that was our little AI agent. Okay, that simple application. It has SQL Server on the back end. It's running in Azure, and that's basically it. So let's go through. Let me pull up. All right, let me pull up the Kanban board. So we've got some things going, some work items that we'll come back to, but let me just show one thing. All right, so we have our application and here it's running, and here is the health check. Let me just refresh that. Let me show production incidents. So in AI software factory, one of the things you want to automate is making sure everything's healthy. So I'm going to click a button off to the side that's basically going to trash one of the processes in the environment. And so if I come back and refresh this, we can see that, okay, server health check, unhealthy, server health check returns, blah, blah, blah. There we go. And if we look at, can't we look at detailed? We might actually, the other URL. I need to go to the server health check. And there we go. The one that's unhealthy, memory is corrupted, restart the process. So if we go to the Kanban board, we can see that a production incident has already been detected, already been filed as a production incident with a tag, and then a cursor session, a cursor cloud session through the SDK has already been assigned and is journaling through the comments. And I can click on that, and I can actually see on cursor.com, I can actually see the session. And if I come back, it happens pretty quick, but all we have to do is kind of bump the server. Hey, something happened, restart something, and then we're back to healthy. And so we'll come back to that because it should happen. It should happen pretty quick. Actually, I think it finished. Well, let's make sure. Let's refresh this, and oh, yep, it's healthy. And so if we come back to our health check, then we should see healthy. And there we go, healthy. Okay, so that's a production incident where there's all kinds of things that just little things that happen, and we can spawn through the Cursor SDK, the Cursor cloud agents that do things, and then, of course, just automatically move the card over. What's important with an AI software factory is that the software development lifecycle and the process that you have figured out what works for your organization, that process be followed exactly. We're not creating a new process because we're automating more of it with AI. We are automating the process. And so putting a production incident on the board on release queue is what this team has done right next to the production. It doesn't need to go back through the development, but in release, and then we work it and we resolve it, and then we move it to done. Okay, so that's tracking. Now, if we were to turn on, this SDK under the covers, I might say add work order constructions as a new field. Okay, I can do labels. I can say that uh, we are going to, was this ready to move? Yeah. I have a few labels, and I have some, my AI software factory scripts running under the covers. And so add work order, this is what, 9153. And it should pick it up and delegate it to the Cursor SDK under the covers, start a cloud agent, and just start working that one. In addition, um, I can, if I move this over, and I'm going to pop up the cursor CLI, the cursor agent. Okay. And I'm going to open this guy. There we go. And so what I'm going to do, make sure I'm configured. I have this configured with access to the board. I'm going to take another one. Make the login. Let's see, what is this? 91. Yeah, 9155. Okay, let's do that one. And I have some skills here. I'll do work 9155 with feature loop. Okay. And so I can set that in motion. All right, what's another one? Because I want to take, and that's gonna go. But I want to take another, where's my other terminal? Okay, here's my other terminal, and I'm actually going to use the remote. I'm going to create a local worker so that I can use this computer for multiple agents. And by the way, let me pause. You see this, the command line, it is mapping to my existing software development lifecycle, the columns on my board, conceptual definition, user experience design, technical design, test design, development, functional testing. And it's starting, okay? So what's important with any board is that your coding column is in the middle. All right, let me take an aside. Your coding column is in the middle, and if I shrink this down, and then you want to have a mirror on either side. The items, the columns to the left of the column where you write the code, you do a feature branch, you write the code, you do a pull request. The coding column, we call it development. The columns to the left of it are making decisions about what we want. We're making design decisions. And so conceptual definition is you're thinking about what's the concept here? What's the overall business requirements, the business goal? Then UX design is how do I want someone to use the software? And then technical design is how am I going to make this actually happen and technically work? And let me start breaking down the technical work to make it happen. And then the test design owns the definition of done. It's like, okay, when this is all done, when this is actually in place, how am I going to test it to verify that it is complete and works the way that we said it should work? And armed with all of those decisions, then it's pretty clear what code to write. And then after the fact, you see we have validation or testing columns that basically mirror the design decisions that we made before development. First, we're going to test that it functions and is complete. Then we're going to test the user experience from a market or product perspective. And then the release queue, we're going to test to make sure that it's actually going to work downstream, that it's releasable, open telemetry, observability, all those things. Okay, so you saw one was moving across the board. And then you can see the 9155 is kind of in UX design. All right. So let's go here. Let me start this. Okay, and this makes my computer, which is quite powerful. Most of the computers that you're using are quite powerful. It makes your computer the runner. So now I have my I'm gonna pull up my phone, and I am going to move over the camera. This is my phone. And now when I go here, instead of selecting a cloud environment, I can see that one of my desktop computers is available, and I can dispatch another work item. And I actually didn't get a number. What work item do I want to dispatch to this guy? Let's do one of these APIs. 9158. Okay, so work 9158. Actually, I can be more terse than that. I can say feature loop. And that's one of my skills that kind of defines my software delivery lifecycle. And by the way, you notice that I'm using auto cost for the model. When you put in place all of these stations of work and your quality gates and organize the AI DevOps environment properly, you actually unlock the power of all of the models that are not the most expensive ones, and they're really useful. But if you don't have any of that structure in place, the only way to get reasonable output, and it's still not perfect, is by spending way overspending on the most expensive models. Okay, so we can see that it's now working and it's actually using a sub agent that we're showing here. All right, that's basically the iPhone, and we're using our computer. That's one flavor of it. So let me pull this back over, and you can see this just kind of sits in your terminal, and you can walk away. You can make your computer available if it has some specific things, if it has, a Docker setup that's specific for you or whatnot. And or if your computer, you have some, some .NET user secrets on your computer that you want to use for some things, you can set this and walk away, and you can go to the gym with your smartphone, and you can just be exploring some things. And actually, I did that last night. I do it quite a bit, just to be able to have my computer at my disposal, but an easy interface with it from the iPhone. Okay, so that's another flavor. And we're also going to um, let's see, click away from here. And this login button, it's gone to technical design. I want you to see that while it's happening, we have more information being augmented in this work item. And so most of you have uh, built up some context in a session window, and the problem with that is that you have to have everything in a single session. But once you start using sub agents, you take advantage of all this optimization, but you still have to have the context of what you're working on available. And so I found that, and not just I, everybody's finding that the actual work item in your work tracking system, well, guess what? If you're doing everything manually without AI tools, you're going to put the context of what you think about this item in the work item. So if we're simulating our current process, then what should the AI tools use? The AI tools should put the accumulated context and information about how we're working this work item in the work item. And you can see we have a comment, and of course it's using my identity here. A comment with conceptual definition, a comment with user experience design, and that, oh, it's complete. A comment with the technical design. The AI tool, the cursor session inspected the existing code and determined what tasks would need to be appropriate, and even might have suggested some prototype CSS code. You can have it be as verbose or as terse as you want. And some things, oh, these are out of scope, so no big deal on that. So technical design is complete. Oh, look, test design just got posted while we were looking at it. And so it's even specifying, actually, this text is kind of small for you guys. It's even specifying, if we go back down to test design, some candidate tests, okay? And what the test should do for the full system acceptance test that actually click on links using Playwright and whatnot. All right. So by the way, this is a lot. For questions, throw them in the chat or the Q&A panel, and I'll make sure to get to them. All right. So that is just a few ways to get some things going. All right. I want to show you additionally, and I'll come back to it, Grokbot. So let's take another one of these guys. Let's take another one of these APIs, 9161. All right. And I'm going to pull up my Grokbot, and I'm just going to tell my scribe. My scribe will coordinate for things. All right. I'll say, wait, which one did I say? 9159. Okay. 9159. 9159. Approved for feature loop dispatch. Now, feature loop dispatch is another one that can actually take multiple. So, let's give it multiple. Let's give it also 9163. 9163 approved. Make it happen. All right. And we'll come back to that because I'll tell you how Grokbot works in a little bit. But let me come back to it because this is a big demo. And ultimately, when you have all the different flavors of cursor running, you're orchestrating things and things are moving across the board and work is getting done. And it's important to have a great process and break down work into uh, easily implementable tickets. It's always been a great practice to create a work item that can actually be done by someone in a a given day within one day. And so if you do that, then it turns out you can actually get a lot of them done by AI tools. Now, of course, we don't want AI slop. We don't want crap. And so we're gonna see how you actually orchestrate all of the different parts of the Cursor platform so that you get the code that you are happy with. That is so important. You need to be happy. Oh, look, another production incident popped up and is being worked by another Cursor session. And it looks like I clicked a button off to the side, by the way, just to approve all of the other work that's going through. So all the other work is getting picked up automatically and is being worked. All right, let's go back. Let's go back and keep moving on. All right, so simple application I already showed you. Now, here's what our build looks like in GitHub Actions. Notice that a lot of these jobs run in parallel because we need to keep the build time short. Okay. Now, with the advent of continuous integration back in 2005, 2006, we kind of learned about the concept of, or we as an industry learned about the concept of a software build, and you should have one. But if you have one, then you add up all the different things that need to happen, and you could have a build that's 10, 15, 20 minutes, 30 minutes because you're doing all the things. But if you really dissect it, not all of the things have to run sequentially. And so by taking all of the piece parts of the conceptual, what a build needs to be for your software, and figuring out which of them can run in parallel, you can keep the timing of your job down. It's so important with AI-driven development to keep the overall time of the build down. All right. So we have a total build time here of 6 minutes and 48 seconds, but we're doing a lot of stuff. We're doing our integration build, but we're also checking it against SQL Server, also SQLite. We're checking it against running on ARM processor versus Intel. We're checking against Windows versus Linux. And then we're publishing release candidate to Octopus deploy. Okay. But it's important that it runs fast, and I'll come back to tests because you absolutely need tests. All right, so let's dive into that. This is a quick rendering from the actual software. Yes, it was generated by Cursor, but it's from the actual software for how many tests of each type that we have to make sure that we actually have a testing pyramid. And you can see we do have a testing pyramid. We have our unit tests, which we have at this time 273 of those. We have 119 integration tests and 88 full system acceptance tests. And so we, in fact, do have that. All right. It's a real quick prompt to build your testing pyramid. So I encourage you to know what the shape of your testing pyramid is so that you can know what to work on. Okay. Now, let's dive into the actual Cursor platform. All right, I want to talk about the platform. A lot of pieces, a lot of pieces. In 2023, you had the public launch of the AI native editor in VS Code. Right? And then code-based indexing came along. We had the inline AI autocomplete, tab, tab, tab. And the first AI code review capabilities, the Cursor bot integrated for code review. In 2024, we had the first agent that uses the terminal. In 2025, we had Cursor rules that came around and MCP support. 2025 was the year of the model context protocol. We had the agent view becoming the default experience instead of just the VS Code IDE. And then we had BugBot for automated pull request reviews. Then we had background agents, memories feature. I think we went up to 8 parallel agents with rules and commands being able to be shared among the team. And now in 2026, it's accelerated even more. The command line interface has the plan, ask, as well as auto mode, and also the cloud handoff and cloud environments. We had the second generation models, Composer 2.5. The IDE was rebuilt around the agent's experience with design mode. The whole thing was kind of changed to be optimized for long running work instead of prompting while looking at every function of code internally. You had agents that you could kick off and just kind of go to lunch and come back. The uh, Cursor was in the summer acquired by SpaceX and XAI and is integrated Grokbot. And so now there's so many ways to use Cursor that you can take your pick depending on what you're trying to do. Are you doing a prototype? Are you refactoring some really tricky and complex code where you need to be in the code side by side? Or are you doing something super, super easy where you can just kick something off and go to lunch and come back, or kick off some analysis, or even some exploratory manual testing, kick it off overnight and come back in the morning and see what broke. So there's so many ways to use the Cursor platform. And if you look at some of the industry surveys and studies of people using AI that is older than, let's say, a year and a half old or 2 years old, invariably the respondents to those surveys will be Cursor users because Cursor was the first mover. All right. Now, I want to stress that Cursor it is no longer just the editor in VS Code. You've got the same agent capabilities, the same rules, the same context that kind of follow us along every interface type. And so the standards that we establish and apply anywhere, that they just automatically get used. All right, you know what? One thing I forgot to do, and I'm remiss. I'm gonna fix that. I actually didn't kick one off in the Cursor agents window. And so I'm going to do that right now. And let's see, one thing, you know what? They're all moving across. So I'm actually I'm going to use Cursor to define one. So let's see here. I'm going to use a cloud environment. I'm just going to make something easy. Windows H. And now I'm transcribing into the window. Create a work item on the project board to give me 3 new options of user experience design with some different color schemes. Don't implement them. Just give me some candidate screenshots in UX design. All right, there we go. So now I've got the agents view, and I can open up IDE, but that's been around for so long, most of you are even familiar with it. But I just wanted to kick one of those off, and that'll get going. It's creating the cloud session. The cloud session that takes a little bit of time to get spun up. You can see now that the name happened, it's starting up. Okay, we'll come back to that. All right. Now I'm really excited to kind of talk about the architecture under the covers because Cursor is designed intentionally to be able to use any model that is out there. It can auto route across various models, and more the choice of which model to use isn't as important as how you integrate the platform. But at the same time, you've got the composer line for fast agentic coding. It doesn't need to be good at everything. It needs to be good at coding. And then you have the Grok line of models that is really top tier already. Okay, so I've kind of gone over the different ways to use it. So I'm just going to go forward so that we can get into the next demo. Okay, so cloud development environments via the SDK. I want to talk about that a little bit more. I showed you that we can already kick one off automatically and use the cloud environments. What you're going to get is a VM. It simulates a VM, and you're going to get basically four virtual CPUs. You're going to get 16 gigs of RAM, 256 gigs of disk space. Um, but this is unofficial, by the way. There's no commitment to these. But if you just run some scripts and you check, hey, what is this running? That's what it's currently running. I think the Grokbot VMs, which I'll talk in a little bit, give you more CPUs. So these will probably be upgraded a little bit. Okay. All right. Let's go forward. All right. One of the things that Cursor is really good at is um, is doing design and making little videos, little demo videos. And so I am actually going to play this. There's no audio, but just you can kind of see a demonstration. All right. And I'm actually going to, well, I can fast forward a little bit, but you can see that it actually runs the application through. I just recently in the last couple days, it implemented something and I said, create a demo video, make it standard to create a demo video every time a new feature comes online. And so that's what this is doing. It's a new demo of the due date. I added a due date field so that we could see when a work order was going to be due. And if it's the same day, then it's yellow. If it's past the due date, it's red. Okay. So you can create videos directly in here. All right, let's go to, you know what? Before I get into that, I want to show you a little demo. So let's go back to Grok. Oh, you know what? Let me check on our cursor agent. And there we go. It's working. Okay, sweet. And let me go to Grok. All right, here is Grok. And behind Grok, we are going to have the application. All right. So actually, I'm going to go to the AI agent screen. I'm going to put it on the left-hand side. And I make this a little bit bigger just so we can do it. Okay. And sorry, I'm managing Windows. All right, let me go to I have a bot that's not working on the software, but is our work orders admin. All right, so ST Lovejoy. Um, have groundskeeper Willie mow the grass every Saturday for the next 10 weeks. Create and assign those work orders. Okay. And here, show work orders assigned to you. Willie. So the left side, I'm in the application itself, and I could go to the search screen and look for the records. Um, and uh, that was actually fast. I didn't even get the response I expected to be able to see. Okay, so we got a lot going on. And okay, so let's see, create a 10 assigned to Willie starting this Saturday. And let me go to search, just so you can see. The creator is Timothy Lovejoy. Actually, this is easier to find. Groundskeeper Willie. Groundskeeper Willie. There we go. Search. No, not Todd Flanders. Where is he? Where is he? I'm going to blank him out. Search. All right, there's all the ones. And the ones at the bottom were just created October. Yep, there we go. Mow the grass, mow the grass, mow the grass. And then I'll come back and say, cancel them. All right. and canceling those. And we should be able to refresh and see that instead of being assigned, it just did it. Search and search again. Then I have to refresh. I think I have caching in here for that. All right, so groundskeeper Willie, search. And oh, canceled don't even show up. So they're gone. They're totally gone. Okay. But I can go back to my AI agent just to prove it. Show recently canceled work orders for you, Willie. All right, what I'm showing here is that yes, our application does something. It keeps track of um, they're canceled. Of course, they're not assigned. They're gone. Uh, we can use the old, forms over data view where I can assign it to groundskeeper Willie, mow the grass, or we can now use our chat agent built into the application, or we can use something like Grokbot or practically anything to integrate with the MCP server that our application is exposing. Yes, our application has web APIs, but the MCP server is the integration over to any kind of language model tooling. And so Grokbot, it is so easy to integrate with everything. So I could do this directly from Cursor or anything that has MCP support. But now if the team is working on the application, I can even set up a test environment by just saying, hey, set up some test records or reset the test data back to so and so. And I can have easy MCP server to my pre-production environments. It's infinitely flexible. So I just want to highlight Grokbot over there. Now, let's come back and let's talk about what this is. So Grokbot was launched literally this month, and it's available through Cursor Ultra and Cursor Teams Premium, as well as the Super Grok Heavy. And behind the scenes, there is one persistent cloud Linux virtual machine server under the covers, and you can actually use it. So if you've never seen it, if I open this up, this is the computer that is actually using, and I've got web, I've got terminal, I've got uh, the file system, and you can see that there's been doing uh all kinds of things on here. Willie, I like groundskeeper Willie. So all right, so that's an actual computer, and it's a computer, and you can drive it, and it's pretty. What happens is there is one of these VMs for your Grokbot pane. So all of the different bots use the same VM. Now they're going to use a different UI session. So they're not going to stomp on each other, and they can use MCP servers. They can use APIs. They can also just navigate to some web application with the browser and mimic anything that you could do with a browser. You can have up to 50 bots share the same VM. And whatever a bot is doing with that VM, you can jump into that VM and take over. Okay. And it runs on, uh, Grokbot has an application for Windows, for Mac OS, and iPhone. And um, you can set up some credentials on the VM. You can store durable work in a certain file structure, and so one thing that it's incredibly useful is testing. Okay, overnight, just have it do manual testing, run through all of the functions of the application, even beyond your automated test suites, and just poke around and see if there's anything that can be made to throw an error, for example. It can capture screenshots, it can create remotion videos. Actually, that's one of the things that uh, that I found tremendously useful. When you're doing unattended uh, AI driven development, you want to see if it was good. And so I'll come over here and this let's see, QA engineer. Yeah, we have this video. And so let's see, I downloaded the video. Where's the video? Um, Here we go. And so I just had to do an easy demo flying through, and it actually drove the real application and captured real screenshots, and then just do it, and then oh, here's the plans for the work order system. Okay, so it does videos, but also actually I don't want to do that. Also, if I scroll up, I mean, there's all kinds of testing sessions that it can do, um, and I have it just use the AI agent, some tweaks to that, and actually create a demo of the feature or a demo of the pull request. And so that's cool too. And even screenshots. I mean, your test can do that, but now everything that's happening. Okay, there we go. And for the let's see, architect. Just this morning, just so that it was ready. I asked for a updated architecture diagram because we've done a lot of things to this application. And I said, it's okay, let's review any changes to the architecture diagram. And so we can see that this work order system, you can see the boundary here. We have a server process, we have a WebAssembly process, the presentation layer, and then we have Azure SQL, and we also have Grokbot over on the side integrating with the MCP server that is actually running in the main web process along with the UI serving APIs up to the WebAssembly application. And then we have a worker off to the side that does things. So there's so many different ways that you can imagine just defining your eyes. And there's also work groups, and they'll chat back and forth. But you can see the bots messaging each other. So the scribe is messaging the coder, and whatever your process is, you can model the process and then monitor the work. And by the way, you're going to dispatch the work that's easy. You're going to reserve the complex engineering for yourself. After all, you are the software engineer. We want to delegate to the computer anything that can be delegated to the computer. Um, and when we do that, it frees us up to work on the truly complex problems that don't have obvious solutions. It frees us up for actually working on the problems that really require engineering. So super excited about that. Okay. Here's a screenshot. I've already showed you that. But here is a video of 16 hours where I put in a whole lot of work items, and it's a video of 16 hours of the Grokbot team working on probably about 12 different features that added in. And then I just had Grokbot use FFmpeg to speed up the video so that it would fit in a shorter amount of time where I could actually show it to you. So this is basically 16 hours of the Grokbot team, interacting and just going to town and working. All right. And so this is how uh, you can see that um, you can see the technology that's going to enable the feature pod organization of a software team where you can pair a market expert and a software engineer around a major piece of functionality, and you can really figure out the hard parts of it and what you want to do and how it needs to be designed, the proof of concept, the architecture, all the hard stuff. And then as you break down the work and identify, the easier tasks that are well defined, then you can delegate them to the computer. All right, but I want to show you a few more things. By the way, this is the architecture of Grokbot, because we always think in architecture. I'm not going to go into it, but let me go the final question. Is this build of the software good? Super important. Yes, we can generate a bunch of code, but we're not talking about just vibe coded brand new games or vibe code Minecraft. That's trash. We're talking about business critical software applications where if you get it wrong, you disrupt the business. We can't have that. We have to have good output. Our software factory has to give us good finished goods. And so we need to map out what we're doing. We need to measure as we go. We need to analyze the product. We need to have diagrams. Pictures worth 1,000 words. We need to think in pictures, and then we need to report on how things are actually going. And the DevOps environment that you've worked so hard for, that all is needed, and you need to up level it. You need to increase your quality assets. So let's talk about what quality assets have done. By the way, this is only the top third of our AI DevOps poster. And if you would like a high resolution copy of our AI DevOps poster, the full thing, then just ask us in the chat or send me an email and be happy to send it to you. I know you can't read all the words on the screen, and I'm not going to go through all of it. I've had other trainings in the past where I deal with it. All right, but let's talk about quality. All right. Um, we have to know good quality. And so let me go to our build, and in our build, you can see our crap score, and you can see the crappiest code files. They're at the top. Now, this application's average crap score is 1.9. Now, if you have never heard of the change risk anti-patterns analysis, then you need to be using it, because I guarantee that your code base probably has some change risk anti-patterns. But I don't want to say that anymore. So I'm going to say chances are your code has some crap. All right. And this is how you measure it. It's free tools. And so what we want to do is measure and have the build break if AI gives us change risk anti-patterns, because we don't want that. Okay. And so we want to measure it, and we can see that if I have a relationship between cyclomatic complexity and test coverage, and I can see my tests, and I can see the average coverage. By the way, the lowest ones on this list have 100% test coverage, but they have a score of 5 because it's all based on cyclomatic complexity. The things at the top of the list do have gaps in test coverage. So the best thing that you can do is get test coverage, because that proves that even if the code could be made simpler, it proves that the test does work. And if we accidentally break the tests, we're going to find out. Also, static code analysis. SonarQube, Roslyn, Codana from JetBrains, those are important. So what I'm showing you here is a Codana scan, and we're scanning every file for all kinds of rules, scanning it for accidental code duplications, because we know the language models like to duplicate code, and we're going to test that and get a baseline, and then we're going to set that baseline so that in the future, if we introduce any new violations, then we're going to fail the build, and then we can, as we go along, we can set some agents working overnight to resolve some of the things that it did find initially, and ratchet up the quality. That's important. We want to ratchet up the quality. Okay. Our clear measure intelligence scorecard gives you the ability to know how are things going. And so uh, if I'm going to pull over this version of it, and you want to see week by week how much work that you're doing and what's going on. So I can see the work, and I can see the columns that it moved through. I can click and drill down, and I can see on the GitHub board what happened with that particular work item. Click directly into it. And one offer we have, actually, let me pull that back. It's on the wrong screen. So we do that again. Now I'm on the right screen. You can click what work was actually done. And if we see we had some production incidents, and we can click directly onto the GitHub board, and then you can see what happens. Now, one offer we will make, we have a Microsoft Excel version. And if you go to your, not that one. If you go to one of your work tracking boards, I have an old client project that we have permission to use. There's a lot of work in here. And if we go to uh, paste in our work tracking board, you can select whatever tracker you want, and it'll detect the organization, the project. You give it a security key, And then in Excel, it'll harvest your historical metrics for your throughput, your defects, your production incidents, and you can drill down and you can use those. All right, so actually, let's go to there we go. And now click, it pulls open the work items, and you can see exactly what happened. You can click over to your work tracking board. All right, so if you're interested in that, then just ask us. We'd be happy to get a scorecard set up for you so that you know how things are going, so that you can understand what your throughput is, what your defects are, what your stability is for your team, and deliver your executive level metrics based reports to your team. There's also two cursor skills that you can plug in. At the beginning, I showed you I was using feature loop and feature loop dispatch. If you would like to use these feature loops, then sorry, if you would like to use these cursor skills, then go ahead and send me an email or ask, and be happy to get these skills to you, and you can use those instead of inventing them. The feature loop dispatch can dispatch an epic or multiple work items, and then it wraps the feature loop, which takes you through the whole board and runs all of your quality gates and tests and everything, and then gives you screenshots through the back end and make sure that you are monitoring your builds on the pull request and all the things like that. All right. In closing, because I know I'm taking you over, in closing, Cursor is a platform bet that really you can defend. There's 7 million people that use it every month, and half of the Fortune 500. So definitely include this in your tool belt. It's now part of SpaceX and XAI. That acquisition did close this month. And for ClearMeasure's part, we want to empower your team to do world-class software delivery. And that's our mission. That means improving your software so that you can deliver those world-class results. And wherever there's a gap between the results that you're getting today and the results that you want, well, that's exactly where ClearMeasure comes in. So you can send me an email, give me a call, or I'll leave it up on the screen. And I know that was a lot of information, but we want to help your team deliver absolutely world-class results. And that's why we get up in the morning. So give me a call or send me an email if we can help you do that. And I think I was able to uh, answer the questions that came through in line. And if there's any others that I didn't, I can follow up with an email and do that. But I appreciate your time. Thank you so much. And we look forward to helping you empower your software delivery.